Hi everyone, I'd like to please ask you to like and subscribe to get more of the content that I make for you. Okay, so today we're going to work on symmetry. Now in graphs, we can be symmetric in a couple different ways. Symmetry of graphs. Okay, so the main methods of symmetry, main types. So types of symmetry. Okay, there are three. So we can be symmetric about the x, so x-axis, about the y-axis, and on the origin. Okay. So these three are the only ways that we can do a 2D graph. There are 3D ones, but those are a lot of a higher order, so we're not going to focus on those. We're going to look at each one individually. I'm also going to try and draw some graphs for examples. Alright, so the first type is symmetric over the x. Symmetric with respect to x. Okay. Oop, missed that. There we go. Okay. So to be symmetric with the x-axis, our points have to look a specific way. There are two ways to figure this out. So our normal point x comma y, must be x to the negative y. So both of these types of points must be there. So for every x I have, there has to be an identical and opposite y. So a great graph that shows this is the graph of x equals y squared. So that's going to look like this. So here's our x-axis. Here's our y-axis. And let's get a different color. I'll do it in blue. Okay. And that would be the rough sketch of a graph that's symmetric to the x-axis. All we want to find for these is if there's a mirror image. So the top has to be the exact mirror image of the bottom and vice versa. That'll allow for this relationship, the point x comma y to the point x comma negative y, to be true. To check for this, we could also do the algebraic version of it, of physically plugging in positive x and see if I get these same and opposite y's out as an answer. Okay, so let me stop drawing for that. A good example of this is the graph x equals y squared, which is the one I did just draw. Another way of writing that actually is y equals the square root of x, the plus and the minus square root. So, or y equals plus minus the square root of x. In order for it to be symmetric, we'd have to have the positive and the negative of it. Okay. So that's for the x. The next one we can look at is for the y. The next is symmetric with the y. Symmetric with respect to the y-axis. Okay, that's very similar to respect with the x. So I'm just going to copy that. The main difference is instead of the y changing, it's now going to be x that's going to be changing. So x comma y goes to negative x comma y. Again, this is going to be a mirror image across the y-axis. So let's grab another quick graph or sketch to see what that looks like. Okay, so that's the x. That's our y. The best graph to show this kind of relationship is a parabola. I'll do my best to draw one that's symmetric. So parabolas are the point or the function y equals x squared. Okay, so that's a great example of ones that are symmetric across the y, because the left and the right are mirror images of each other. Okay, and then the last one is going to be respect to the origin. So again, let's get rid of this. And the last one is respect to the origin. With respect to the origin. For those that don't remember that word origin, it just means the center of the graph where the x and y axes meet. Okay. The best example for this is we have x comma y goes to negative x comma negative y. That's the main formula we look at. And the best example for this is just a line like y equals x. This way, when I plug in a negative x, I get the negative y of that answer. Okay. Well, I hope this was helpful and informative. Again, please like and subscribe. If you want to see something specific, please let me know in a comment below. I'd be more than happy to do that video for you. Again, I hope this was helpful, and I hope to see you again soon.